All right, boys and girls, so let's pick up where we left off. So I stated that we drew a number line right here to help us understand if our estimate or if our answer is in fact reasonable based on our estimate. So our number line drawn represents one whole broken up into 24ths. Now, our half point or 1/2 will be 12 over 24, which will represent 1/2. And our whole, 24 over 24, which is right here. Now, our answer is 17 over 24. So our answer lies between 1/2, 12 over 24, and 1 whole, 24 over 24. So this means our answer is in fact reasonable based on our estimate. And we estimated that our answer will be between 1/2 and 1 whole gallon. So for our answer E, we will write out, yes, my answer, 17 over 24, is reasonable because it is between 1/2 and 1 whole. Now let's move on to the next page. Our next page tells us the number line below shows the location of benchmark fractions between 0 and 2. You can use these fractions to estimate sums and differences. There are different ways to estimate the sums or difference of fractions. The examples below show 2 ways to think about fractions to find estimates for the amount of water Elena used to water her flowers. And the equation was 3/8 plus 1/3. Student A says 3/8 and 1/3 are both less than 1/2 or 4/8. So the sum must be less than 1 whole. Student B says 3/8 is a little greater than 1/4. 1/3 is a little greater than 1/4. I know 1/4 plus 1/4 is 2/4 or 1/2. So I estimate the sum is greater than 1/2. Now we're going to reflect on what both students wrote, and we're going to see which student's response makes more sense. Now, keep in mind, both students' answers are correct, and they do demonstrate correct thinking, but we want to see which one makes more sense to us and why. So let's go ahead and evaluate. So student A says 3/8 and 1/3 are both less than 1/2. So let's go ahead and see by using our number line. So if we're looking at our number line, I drew our number line right over here again, and we're going to break up. The easiest way to evaluate this response is to break up our 1 whole into how many equal parts. So we're going to start off with 3/8. So right now it's broken up into 4ths. So I can break up my 4ths into 8ths by breaking it down 1/2 again. So I'll break up my number line into 8ths. So I'm going to break this into 8ths. So if I broke up this into 8ths, now I'm going to count 3/8. 1, 2, 3 right here. So let me go ahead and circle this. So this point right here will be 3/8. Now, is my 3/8, which is right here, less than 1/2, which is right here? Indeed, yes, it is. Now, let's go ahead and evaluate 1/3 and see if 1/3 is less than 1/2. So the best way for me to do that is I'm going to draw another number line above the number line that I have right now. And I'm going to break my number line into thirds. So I'm going to break it into 3 equal parts, 1, 2, and then my 3rd part will be right here at the 1. So I broke it up into thirds, 1 right here, 2, 3. Now, if I were to identify 1/3, it will be right here. Now, is my 1/3 right here less than 1/2, which is right here? Yes, it is. So student A's response would make the most sense because they use the number line effectively by showing us that 3/8, which we identified and 1/3, which we identified, is less than 1/2. So the sum of both fractions must be less than 1/2. So as always, we need to write in complete sentences. So we're going to say student A's estimate makes more sense because it's easier to see how close the fractions are to 1/2 and 1/2 than compared to the other fractions. And go ahead and write that down in your packet at this time. And after you have done so, let's turn to the next page. All right, so the next problem says Frankie purchases a 3.5 pound bag of chicken and he uses 1/3 pound of chicken for fajitas. How many pounds of chicken are left? So by breaking down this word problem, we're going to look for the keywords and we're going to look for left, which is a keyword. And that's going to tell, and purchase is a keyword. So if he purchased a 3.5 pound bag of chicken, and use is a keyword because use means he's going to get rid of, and he used 1/3 pound of chicken, how many pounds of chicken are left? That means we're going to subtract because we need to take away 1 and 1/3. So let's go ahead and read our explanation below. Below, they have pictured with fraction strips. And it says you can picture the problem using a fraction strip. The fraction strip below represents 3.5 pounds of chicken, and it is separated into sections representing the 1 and 1/3 pounds used for fajitas and the unused amount. So if you look at the fraction strip right here, there's 1, 2, 3 whole parts. And then there is a half of a whole right here. And it says we used 1 and 1/3 pounds. So the blue area is the 1 whole and the 1/3 pounds that he used. And again, we had to break this whole part into thirds. So to show that we have 1 and 1/3 used. So the model shows the difference of 3.5 minus 1 and 1/3. Now, another way besides showing a visual model, we can model it using a number line because again, you can do math several different ways. Now the model shows a number line and it says since 2 times 3 equals 6, the fractions in the problem, 3.5 and 1 and 1/3 can be rewritten using a common denominator of 6. Again, because when you add or subtract fractions, you must have common denominators to make them equivalent so you can add or subtract. So the least common denominator for the 2 and the 3 will be 6. And that will give us 3 and 1 6 and 1 and 2 6. The number line below is divided into 6. It shows starting with a total of 3.5 pounds with 2 jumps to the left representing the 1 and 1/3 pounds of chicken used. So let's go ahead and break this number line down. So we have 0 to 4 because we started with 3.5 pounds of chicken. Again, we started with 3.5 pounds of chicken. Now, if we were to use the common equivalent fraction with the common denominator of 3 and 3 6, this will also be 3 and 3 6 because let's see, each whole part is broken into 1, 2, 3, 4, 5, 6 equal parts. So 3.5 is equivalent to 3 and 3 6. So if you look to the right of the screen, I identify that 3.5 is the same as 3 and 3 6. Now we're subtracting 1 and 1/3, which is equivalent to 1 and 2 6. So if we jumped over 1 whole, 6 over 6, which is our denominator, 6 over 6 would equal 1 whole. So we're going to jump back 1, 2, 3, 4, 5, 6 places. And that right there is our 1 whole part that we jumped back. Now, we still have to subtract 1/3, which is the same as 2/6. So we broke our whole units into 6. So we need to go back 1, 2, 6. So let's go ahead and write that down next to our 1/3. 2 over 6. So we know that those equal the same thing. And that lands us to right here. So that means our answer would be, so our answer would equal to 2, 2, and 1, 6. Because we have on our number line, we have 2 whole parts left, and we have 1/6 of our total left. Because again, each whole part is broken into 6 equal parts, and we have 1/6 left. So our answer would be 2 and 1/6. Now, if we were to use standard algorithm, we could simply do 3 and 3/6 minus 1 and 2/6. Remember, we always subtract our whole numbers first. So 3 minus 1 will give us 2. And then we subtract straight across. 3 minus 2 is 1. And our denominator always stays the same. 2 and 1/6. So now let's finish up by going to the next page, and we're going to answer 2. So we're going to use the number line, the benchmark number line right here, to answer our following questions. So it says identify the closest half on either side of 1 and 1/3. So again, we identified that 1/3 is the same as 2/6. So 1/3 will be represented right here. So 1/3 will be represented right here. So the question says 1/3, 1 and 1/3 is greater than, so 1 and 1/3, this area right here. So we know that 1 and 1/3 is greater than what number? It's greater than 1, and it is less than what? 1/2, which will be right here. So for number 2, our answers to fill in the blank would be, for 2, we would have 1 and 1/3 is greater than 1 and less than 1 and 1/2. Let's move on to 3. Why are halves a good choice for benchmark fractions for 1 and 1/3? So halves are a good choice because, again, in our previous problem, we were subtracting by what? We were subtracting 3.5. So that is a good choice for us to use halves when we are looking at benchmark fractions. So for 3, we would say halves are a good choice for benchmark fractions because we are subtracting from 3.5. Let's move on to 4. The difference, 3.5 minus 1 and 1/3, must be between what two numbers? So we identified that the difference of 3.5, which is right here, minus 1 and 1/3, which we subtracted right here, must be between what two numbers? It must be between 2, and it must be between 2.5, which is right here. So our answer is smack dab in between 2 and 2.5. So for 4, our answer will be 2 in the first blank and 2.5 in the second blank. And then it says estimate 3.5 minus 1 1/3 and explain our estimate. So if we were just to estimate, we would estimate that it would be about what? Our answer would be around, our estimation would be about 2. Let's go to 5. Find the actual difference of 3 3/6 minus 1 2/6. And as previously stated in the video, we identified that that answer will be 2 1/6. So you will go ahead and show your work that we did on the previous page on this area right here. And we would show that 3 3/6 minus 1 2/6 equals 2 1/6. And to complete our sentence, we would say there are 2 1/6 pounds of chicken remaining. Let's move on to 6. Is this a reasonable answer based on your estimate? And we're going to explain. So again, we estimated that our answer should be about 2. And the answer that we came up with is 2 1/6. So 2 1/6 is reasonable because it is around and close to 2 right here. So we would say yes, our answer is reasonable because it is close to 2. We're going to move on to 7. Explain how you can check if a fraction sum or difference is reasonable. So for us to explain how we can check, we can estimate the sum or difference based on the size of the fractions. Once we estimate the sum of the difference based on the size of the fractions, we can then compare our answer to the estimate given. If the estimate that we gave is close to the answer, then it is reasonable. So again, in order for you to identify if your answer is reasonable, your estimate and your answer must be close. And then for our last one, we're going to try it. It says, Tim's bean sprout grew 3 3/8 inches. Tegan's bean sprout grew 2 3/4 inches. How many more inches did Tim's bean sprout grow than Tegan's? First, estimate the difference and explain your reasoning. Then find the actual difference. So again, we're going to subtract because our keywords, it says, how many more inches did Tim's bean sprout grew than Tegan's? So if we're subtracting, we need to subtract Tim's bean sprouts, which is 3 3/8, from Tegan's bean sprouts, which is 2 3/4. So on your own, I want you to work this out. And when we have our next teams meeting, I want you to be able to explain your answer. And then I want you to work out the rest of the practice problems that you see below throughout the remainder of this packet on your own. Thank you. Bye-bye.